Now let's look at how you can use integration of vector functions to find the position given the velocity and one piece of initial data. Here we have an example where the velocity is given by this function 3t squared 4t 5, and we know that the object's position at time 1 is 10, 9, 8, and our goal is to find the whole position function r of t. So we start by saying that since velocity is the derivative of position, position is the integral of velocity. And remember that you just integrate a vector function component-wise. So in this case we get t cubed, comma, 2t squared, comma, 5t. Except remember what your calculus teacher probably tried to really get you to remember, which was to always write plus c whenever you do an indefinite integral. Of course, the funny thing here is that c is now a vector. Or if you prefer, there's sort of a separate constant in each component. You can think about it however you like. So t cubed plus c1, 2t squared plus c2, and 5t plus c3. Now we would like to get rid of those constants. And since I have this extra piece of data here, I can actually do that. And so the idea is to say, well, on the one hand, I want for 10, 9, 8 to be r of 1. But on the other hand, if I plug 1 into the actual function I have, and let me go back to just this first version here, what I get is 1, 2, 5 plus c. Well, there's only one way to make that equation true. C has to be 10, 9, 8 minus 1, 2, 5. So in this case, 9, 7, 3. And so putting it all together, we've actually found the exact position function. So r of t must be t cubed plus 9, 2t squared plus 7, and then 5t plus 3. And you can check that, yes, now if I plug 1 in, I really do get 10, 9, 8. And furthermore, I can check that r prime, which should be the velocity, really is 3t squared 4t 5. Okay, so with this extra piece of information, you're able to get rid of this plus c and find the actual particular position function for this object. You can do something similar if someone gives you the acceleration and two pieces of initial data. Well, then it's possible to integrate twice and to find the exact position function and velocity function.